All right, we are now in section 10.1. This is an overview of sequences and series, infinite sequences and series. And we're looking at example 1, and it's got two parts. It says, use the explicit formula to write the first four terms of each sequence and then sketch the graph of each sequence. So part A, the sequence is a sub n equals 1 over 2 to the n. So it wants four terms. A sub 1 would be 1/2. A sub 2 would be 1 over 2 squared, which is 4. A sub 3 would be 1 over 2 cubed, which is 8. Oops. And A sub 4 would be 1 over 2 to the 4th, which is 16. And then you're supposed to graph it. So graphing this, you graph the n on the x-axis. I put an A first. And then you put your a sub n on the y-axis. So when n is 1, we got 1/2, and I think I better make 1 be way up here. So 1/2 would be right here. And then 2 gave us 1/4. And then 3 gave us 1/8. And then 4 gave us 1/16. So that's part A. Part B, the function is a sub n is equal to -1 to the n, which is going to cause it to alternate, times n over n squared plus 1. So these are going to take a little more. A sub 1 would be -1 over 1 squared is 1 plus 1 is 2. A sub 2 would be an even number, and then 2 over 5. A sub 3 would be an odd number, and 3 over 10. And A sub 4 would be an even number, 4 over 16, 17. And so now I need to draw this graph. So when A is 1, it's -1/2. When A is 2, it's 2/5, which is about 0.4. So maybe about here. And then -3/10, so about here. And then 4/17, a little bit less than 1/4, about here. And if we kept on plotting dots, we'd see that these dots alternate from above and below the n-axis, and they get closer and closer to the n-axis. Now we're ready for example 2. All right, example 2 is a recursive function. And when you have a recursive function, they have to give you the first term, which in the first problem is 1, and they have to give you a formula to get to the next term. All right, so we have first term is 1. I don't like how they wrote this. Okay. First term is 1. Second term is going to be, you stick the 1 in the formula because you've got to put your answer to the previous term, because the a sub n term is the term before the a sub n plus 1 term. So that's going to give me 2 plus 1 is 3. Then I go to the third term, and I'm going back to that formula. It's 2 times the previous term, which the answer was 3, plus 1, so I get 7. Now when I go to the fourth term, it's 2 times the previous term plus 1, so I get 15. And it appears that there's two questions here. The second one starts out with a sub 1 is -1, and a sub n plus 1 is going to be 2a sub n plus 1. Oops, 2a sub n plus 1. That's not there. All right, so first term is -1. Second term is going to be 2 times -1 plus 1, which gives me -1. Third term is going to be 2 times the previous answer plus 1, so now I'm going to get -1 again. The fourth one is 2 times the previous answer, which is -1 plus 1, and this one is stuck in the -1s. So if you look at the first sequence, they increase without bound. They keep getting larger and larger. but all the terms of the second problem are -1. So the initial term of the sequence may determine the behavior of the entire sequence. So now we're ready for example 3. And I don't know if the whole thing will fit here, but we'll see. It says, in part A sub n is going to be negative. Oh, it's a sequence. Okay, they're giving us the list of terms. -2, 5, 12, 19. And they're asking us to find the next two terms. So well, what's happening? What does it appear to be doing here? It looks like if I add 7 to -2, I get 5. If I add 7 to 5, I get 12. So we keep adding 7. In this example, the common difference in this case is 7. So I'm going to put D as 7. And so the next two terms will be 19 plus 7, which would be 26. And then the next one plus 7 would be 33. Then it says, write a recursive relation. Okay, that means I start with writing down the first term, which in this case is -2. Yeah, they want recursive first. And so then how do I get... They're using a sub 0 as -2. You're going to have to check when you do this. They may call it a sub 0. I typically call the first one a sub 1. That's okay. It still works. All right, so here I have, what is the next term going to be? The a sub n plus 1 term is going to be the previous term plus 7. So that will give me the sequence. And then triple I wants the explicit formula. Well, the explicit formula, we need to notice here that we keep adding a 7 to it. And there is actually a formula for this, but they haven't given it to us at this point. So we're going to have to look at it intuitively. So intuitively, I would say, well, I'm starting with -2, and then I'm going to add to it a 7. And it's going to be the number of 7s that I'm on is determined by how many places I've gone past the term I've started with. So like if I'm on term number 1 and I'm trying to get to term number 3, I would add a 7 twice. But I'm on term number 3. If I'm trying to get to number 5, I would add a 7 4 times. So it appears that I'm always adding the 7 one less than the number of the term that I'm on. So by doing that, I could get a formula for this. This is going to look a little different in the book because, again, they're starting it at 0. So my formula is going to look different. I would say that a sub n is equal to -2 plus 7n minus 7. So a sub n is 7n minus 9, where n, not m, where n is 1, 2, 3, and so on. In the textbook it says where n is 0, 1, 2, 3, so they've got a different formula altogether. You're going to have to look and see in My Math Lab if it tells you what to use for your n's and adjust it accordingly. Part B, the sequence, b sub n is going to be equal to 3, 6, 12, 24, 28, and so on. So now, what's happening here for part I? They want us to list the next two terms. And what is it doing? It appears that it is not adding anything, because if I add 3, I don't get to the 12, but I'm timesing by 2. 3 times 2 is 6. 6 times 2 is 12. So this is called a common ratio, and we usually use the letter R for this. And so the next two terms, 28 times 2 would be 56. 56 times 2 would be 112. For part double I, they want the recursive formula. So again, I'm going to say b sub 1, and the book is using b sub 0. Actually, they're using a's all the way through this. Okay, we'll just use an a then. That's okay. A sub 1 would be 3. And then how do I get to the next term? You would take that previous term, and times it by 2. So it would just be 2 a sub n. Now, to get to the explicit one, again, doing this intuitively, a sub n is going to be equal to, starting at 3, now let's think about this. If I'm trying to get from the first term, which is 3, to, let's say, the fourth term, which is 24, I'm timesing by 2 3 times. So again, I'm on the fourth term and I've timesed it by 2 3 times. So it appears that I multiply by my ratio, which is 2 in this case, n minus 1 times, depending on the number that I'm at. So it would be 3, and then it would be 2 to the n minus 1, and again, n is 1, 2, 3, and so on. The book wrote, and I'm going to put it down here since I have room, a sub n is equal to 3 to the 2n, 3 times 2 to the n, where n is 0, 1, 2, 3, and you'll see that generates the exact same terms. Now, all the way through the series, they've talked about starting at n is 1, but in this particular example, they did them all at 0. So just check when you're doing the problems in the homework to see which way they're doing it. Remember the difference between recursive and explicit. A recursive function is one where you have to give the very first term, and then you use that term to generate the next term. So your a sub n plus 1 always has to use a sub n, the previous term, to get to it. When you write an explicit one, it's explicit, it stands by itself. The formula will generate whatever term number you want because all it uses in its formula is the n for the term number. So that's the main difference there. If I was trying to get to the 100th term in a recursive formula, I would probably cry because you'd have to do all 100 terms. But explicitly, if I want the 100th term, I just got to plug 100 in and I can get the answer. So there are benefits to both. The recursive one is easier to pick up, but the explicit one is easier to work with.